Hello friends, in this video I am going to show you OR gate by diode circuit. This is the representation of symbolic representation of two input OR gate. Here A and B is the input and Y is the output. Whenever any input between A and B is high, then output Y will be high. You all know from basic concept of your digital logic design. Now see here it is the truth table of OR gate. When A and B both are 0, the output is 0. When A equal to 0, B equal to 1, output is 1. When A equal to 1, B equal to 0, output is 1. And when A equal to 1, B equal to 1, output is 1. See, these three cases, the last three cases, whenever any input is high, the output is high. Okay. And see the first case, when both the inputs are 0 or low, then the output is low. Okay, this is the functionality of OR gate. Now there must be some circuit which are doing this job. Okay, what type of circuit can do this type of functions? Let us discuss. This is one diode circuit which can act like a OR gate. I will explain how it is working. See, here A and B, in this portion we are giving the input, and across this point C we are taking the output. Here two diodes are connected. The p type portion of the diodes are connected with the input, and across the n type portion which is sorted we are taking the output from C, and C it is connected with the resistor R whose other terminal is grounded. Okay, this can act like a OR gate. I will explain why. See, this is the same circuit diagram whatever I have shown in my previous slide. Now let us consider the different four cases for two input OR gate. Now let us consider the first case, that is when A equal to 0, B equal to 0. When both of these are 0, both the inputs are 0, what will happen? Suppose A is 0 volt, B is also 0 volt. See, in this portion 0 volt is there, and in this portion also 0 volt is there. That means here across the input and this portion, what is the potential drop? That is 0 volt. There is no potential difference across these 2 points, across this point and this point. Okay, there is no potential drop is there, so that basically no current will flow across this circuit. Okay, in this direction you say, or in the reverse direction, basically current cannot flow. In reverse bias only reverse saturation current flows. So basically no current will flow in this circuit. Okay, so basically across this resistor the potential drop is 0 volt. Okay, so obviously as C is connected, directly connected or directly sorted with the resistor, so that obviously C will get 0 volt. Okay, so it is clear that whenever A and B both are 0 volt, then C is also 0 volt. Okay, I have shown the case when A equal to 0, B equal to 0. See, we can replace the two diodes by open circuit, because in this case, as in the P side 0 volt is there and also it is grounded, so obviously this side will be also 0 volt. So basically no current will flow through this circuit. This is under reverse bias, so obviously we can represent that by open circuit. So C is basically 0 volt. Okay, so whenever A equal to 0, B equal to 0, then we are getting C equal to 0. Okay, now let us consider the second case. Suppose A equal to 5 volt, B equal to 0. We say A equal to 1, B equal to 0. In application in analog electronics, whenever we apply that, digital 1 is converted, is indicates by the 5 volt. Okay, you remember this, and 0 is 0 volt, the digital 1 is represented by 5 volt. So when A is 5 volt and B is 0 volt, what will happen? Let us check. In this case, which diode will turn on, either D1 or D2? We have to use trial and error method. So first let us assume that any diode is turned on, then what is the consequence? Let us argue in that case. Then if the condition does not satisfy, then we switch to other diode turned on, then we will analyze the circuit. In this way we will discuss. Okay, suppose let us assume the D2 diode is turned on. Okay, whose input is 0 volt. If D2 diode is turned on, if we consider the diode as ideal diode, so obviously it will be short circuited, and as this path is short path, so obviously C will get 0 volt. Now see, for this is D1 diode. So for D1 diode, what is happening? The P type is connected with 5 volt and the N type is connected with 0 volt. So obviously the D1 diode will also be in forward bias. So obviously we can replace the diode by short circuit. So see what is happening to the point C. Here C is short circuited with 5 volt and also with 0 volt. So which potential C will get, 5 volt or 0 volt? Basically this is not following the electronics logic. Okay, see, one point is getting 5 volt and 0 volt also, but this is not possible. So this case is not possible. So our assumption is wrong. D2 diode cannot be turned on. Okay, let us see the second case. This assumption is wrong. Now see, for second case, let us assume that the D1 diode is turned on. So we can make the D1 diode short circuit and we get this figure. Okay, here D1 is short circuit. Now let us consider what will happen to D2. As soon as D1 is short circuited, C will get 5 volt. Now see, for D2, the N type is connected with the 5 volt and P type is connected with the 0 volt. That means P type at lower potential, N type at higher potential. So obviously D2 diode is in reverse bias, so we can replace the D2 diode by open circuit. So C is getting basically 5 volt. Okay, so what we are getting, when A equal to 1, that means when A equal to 5 volt and B is equal to 0 volt, then C is equal to also 5 volt. That means C equal to 1. Okay. Now, next case, let us assume A equal to 0 volt and B equal to 5 volt, and let us see what happens for diodes. Now, let us consider the D1 diode is turned on. Okay, when A is 0 volt, B is 5 volt. Now, what will happen? As soon as the D1 diode is turned on, we can replace the diode by short circuit. So basically the output C will get 0 volt. Now see, for the D2 diode, what will happen? Sorry, the P type of the D2 diode is connected with the 5 volt and the N type of the D2 diode is connected with the 0 volt. So basically D2 diode will also be turned on. So we can replace the D2 diode by short circuit. Now again the same problem arises. The C point, the C output C is shorted with 0 volt as well as 5 volt. So this is also not possible. C will not get these two voltage simultaneously when it is shorted. It will get only one voltage. So this thing is also not possible. Our assumption is wrong. D2 cannot be turned on. Now let us assume the D1 cannot be turned on. Now let us assume that the D2 diode is turned on. What will happen? Whenever D2 diode is turned on, we can replace the D2 diode by short circuit. Okay, now see what will this, as C is short circuited, so basically the potential of C will be 5 volt. Clear? Now see, for D1 diode, what is happening? The P type is connected with the 0 volt and N type is connected with the 5 volt. So obviously D1 diode will be open circuit because it will be in reverse bias. So basically C will get 5 volt. So whenever A is 0 volt and B is 1, that is 5 volt, then C is also 5 volt. So we are getting this condition. That is when A equal to 0, B equal to 1, then C equal to 1. Okay. Now see, the last case is A equal to 1, B equal to 1, C equal to 1. What will happen? See, when A equal to 1, B equal to 1, obviously C will be also 5 volt because see, here 5 volts in the input side and here it is grounded. The potential drop across the diode, if you consider the constant voltage drop model, then only 0.7 volt required to turn on. So obviously you can think that both the diodes are turned on, or if any diode is turned on, basically C will become short circuit with the 5 volt and C will get the 5 volt voltage. Okay, so basically when A and B both are 5 volt, C is also 5 volt. Okay, now see, with this circuit analysis we started and we got 4 results. When A equal to 0, B equal to 0, C equal to 0. When A equal to 1, B equal to 0, C equal to 1. When A equal to 0, B equal to 1, C equal to 1. And when A equal to 1, B equal to 1, that means both are high, then C equal to 1. See, from this case, it is clear that whenever any input is high, output is high, and when both the inputs are low, then the output is low. This is nothing but one OR gate. Okay, so inside OR gate we can make this kind of diode circuit so that it can act like the OR gate, that is whenever any input is high, the output will be high. Okay, so this diode configuration acts like a OR gate. This is all for this video. In my next video I will show you some more concepts. Thank you for watching.